Peter, thanks very much for being here. Welcome.
Thank you.
You put the slide back. We're going to get into a bunch of different things, but I wanted to maybe start with the level. So just to make sure that everybody is completely familiar with Shapeways, do you want to tell us maybe in 1 minute what Shapeways is?
Sure. Can everybody hear me? Yeah, that seems like sound is okay. So Shapeways is an online platform that enables everybody to make amazing products come to life using 3D printing technology.
Okay. How does it work at a high level?
So depending on what you want to do, if you're a designer, you know how to use 3D software, you can go to our site and upload any of your creations. We provide really cool tools that help you figure out whether your file is printable and then give you feedback even on manufacturability, because certain things, like if you have a dumbbell with a very narrow stick in the middle, we give you feedback that might break depending on the material you're using. And then when your products are ready to print, we give you feedback on all the materials we have, and you can order them. And that's not it. You can also, if it's a really cool product, talking about a lean way and bringing things to market really quickly, you can open a store, it's for free, you can start selling those products to a worldwide audience. And just recently we added the ability to make any product customizable by just adding hotspots. You just indicate here, want to add text, want to add a picture. End users can see that, so they type and they real-time see the product change, and then they can customize and buy it. Those are the basic steps of what we're providing.
Okay, very cool. So you upload the file, you guys print it, you guys ship it, and you offer a marketplace where people can sell their creations. Okay, very cool. Tell us about your background. So what did you do before this, and how did you come to do this?
So I'm originally from the Netherlands, always been really into technology. Loved playing first with electronics, then with computers, taught myself how to code in BASIC and assembly when I was 13. Decided to study applied physics, but fell in love with the internet back in '91. Played with Linux way too much, and then after studies joined the first startup by happenstance, where a guy had this crazy idea to publish the first free 3D software. And that's where I learned that startups are really, really cool. And so that went to another startup, did broadband internet over satellite, spun out the technology, sold the company, and then I ran into a guy who told me about 3D printing, as we now call it.
Mm-hmm. Who was that person? It was just casual conversations and then led?
No, it was actually someone I worked with before, and he learned about 3D printing at Philips Design. He was actually just starting together with 3 others the lifestyle incubator at Philips to figure out what new cool things they could do. And he called me and he said, Pete, I think you want to see this. And I went to see him at his house, and he showed me some products that were made with 3D printing technology, and I was flabbergasted to learn that there were these machines that you can actually send a file to and then they make it for you. I thought that was Star Trek, and I had to see it to believe it, but then when I saw it, I immediately went back to the friends I had in the Blender community, because hundreds of thousands of people were very passionate about creating stuff in 3D. I figured they might want to transform some of those, or actually get some of those products from the digital realm into the real world in which we live. And I was right. And that was the start of Shapeways.
Okay. And so you moved to New York in 2010?
Yes, actually in January of 2011, but yeah. So in 2010 we opened the office here.
And what was the reason, so as a European startup, to move here and to New York specifically?
So we started Shapeways in 2007, launched the site in 2008, and after we got funding from Union Square and Index, we started to figure where do we want to put our main office. And since our biggest market was already the United States, we wanted to have an office here somewhere. And then put on top of that, a good question from our board members saying, where can you find top talent, but also where can you convince people to move to? And I already had experienced that convincing people to move to Eindhoven is where we started was hard, really hard. There were plenty of things already hard about Shapeways, so I didn't want to add that to the list. And New York has this really cool ecosystem of design, fashion, media, entrepreneurship, so it made a lot of sense to be in New York versus the West Coast. And also because we decided to keep a team in Eindhoven, because we believe that manufacturing should be local, the time zone difference of 6 hours made more sense than the 9 hours to the West Coast. So that's in the end how we landed here.
And does it feel to you as of now that New York is one of the key hubs for 3D printing between you guys, MakerBot, and like a few others, or is that fairly distributed?
It's kind of cool. MakerBot being here, us being here, and then you have lots of other Solidoodle and Souls and
which came out of MakerBot.
Yep. And so more and more companies here are into 3D and into 3D printing, which is really cool. I think there is a big scene in Europe as well. And the Netherlands has a few companies like Ultimaker and 3D Hubs. So, but yeah, there's definitely a lot going on here in that space, which is cool to be here.
Okay, very cool. All right, so tell us about Shapeways as of today. So I'm interested in stats. I just wrote down a number of things. That you had printed a total of 2.5 million products with 150,000 new designs uploaded monthly. I don't know, are those the correct stats? Are there updated ones?
Yeah, it's changing quickly. People are uploading. So I can remember the early days where my co-founder Robert and myself, we were like really scrambling to find like 4 or 5 files that we could print and test through our system to upload and check. And now people upload close to 200,000 designs, product designs that we print every month. And we've printed way over 3 million products. We print actually close to 200,000 a month now. Which is crazy, shipping about 1,000 boxes here from New York and another 500-600 in Eindhoven filled with goodies, and it's growing fast. It's really cool.
Yeah.
And then we have about 600,000 designers that are part of our community, and over 35,000 shops where people are selling products.
And for people like me who care about those things, you've also raised almost $80 million, including very recently, just in July, from
Incaf and HP Ventures, yes, and Presidio. Yep.
So HP Ventures is interesting that so Hewlett Packard, HP would choose to invest in 3D printing.
Well, if if you're into the 3D printing scene, maybe not so surprising, yes, because just before they announced their new 3D printer,
yes,
and we actually decided to work together on that because they wanted someone who was using 3D printers 24/7, and they wanted to learn how to make a machine that would make us happy. So after we started to work like that, I said, like, why don't, we're racing around, you guys should participate, and they decided to.
Okay, so it sounds like you're at this stage now where you're starting to basically scale. So it was this very interesting concept for a number of years, and then it started growing. That now you're scaling. So I'm curious what production looks like at this stage. Do you have I don't know, factory floors with a bunch of printers? Do you have several centers? What's production at Shapeways these days?
Yeah. So in 2010 we decided to do some of our printing ourselves to learn, and also to be part of the conversation with, because in the beginning we outsourced everything. It was easier.
To who?
To people who already own 3D printers, companies who ran services for prototyping. I mean, 3D printing, some people don't realize, has been around since 1989. And so you could say that Shapeways was late to the game in a sense. We were not, probably because we made the clear decision to say that 3D printed parts are actually final products and not prototypes. But we found lots of companies who use 3D printers as a service to provide, and they helped us to make our first parts for our customers. But then in 2010 we decided to print for ourselves, first in Eindhoven because we had the space, and later on we built our factory here. We now have 2 factories where we produce about 50 to 60% of all the products that our community orders. And then we have about 45 to 50 partners worldwide that also print for us. And they have different technologies that we currently don't do ourselves, and they have technologies that we have ourselves.
Oh, interesting. I hadn't realized there was a partner aspect to this, actually, at the origin and still now. So what have you learned about along the way in terms of what works with sort of larger scale 3D production and what doesn't work? What completely failed, for example?
What completely failed? Maybe not a complete failure, but we started with FDM technology because in the early stage convincing someone to print for us was hard. they could see us print 10 parts a week, but we were talking about 10,000 parts and then 100,000 parts. So this one guy did it and he had an FDM machine, Stratasys FDM machine.
Do you want to explain what that is to?
That's basically a professional MakerBot. So before MakerBot, before all the home printers, FDM was a technology that was built in a big machine. Stratasys developed and pioneered that technology, and we found a guy who had such a machine, and we started printing with that. And then, all the home printers started coming out, and actually there was no differentiator between the technology that big machine gave versus the home printer, and it was expensive and slow. We already introduced nylon based on SLS technology, which is using a laser to melt powder. We introduced metal already, and the demand for FDM just dried up, and we decided to cut it.
As of now, you can produce all sorts of things, right? All sorts of materials, 20 plus materials, including gold, silver.
Yep. So we print in various types of plastic, in stainless, all kind of finishes of stainless. We print in silver, gold, platinum, bronze, brass. We also developed actually our own technology to print in porcelain, which is really beautiful, and we do a full color material. Yep.
And you, again, to the question about scale,
yep.
So you can print several objects within a large machine at the same time, or how does that work?
Yeah, so 3D printing is actually a complete misnomer, but we kind of like it, we all together, so we keep it. But there's so many different technologies that are used, and depending on the technology, the printer makes one item at a time, which is happening with FDM, or it makes items on a 2D surface, which happens with polyet and other technology, or it even prints in 3 dimensions, where you can basically fill a 3-dimensional space with as many parts as possible. And to your question about scaling, one of the things we discovered is that 3D printing when we started was horrendously expensive. Never going to be a consumer-ready technology at that price point. So we decided to take a gamble and say, okay, let's assume we can bring the price point down by a certain amount. Let's start selling there and we'll figure it out. And one of the assumptions we had is that we can optimize a lot by running those machines super, super efficient. We've made huge improvements there, using Lean and using Six Sigma, using quick response manufacturing, and we are starting to really get that down. And it's so impressive. Like, I can remember back in 2014, we ordered our last big machines from EOS, and then 6 months later, they called and said, "Hey, how are you doing? And we haven't heard much from you guys. Everything okay?" I said, "Yeah, we're growing like crazy." They go, "But you're not asking for more machines." I said, "Yeah, I know. We just doubled our capacity of products we could make on the same machines in the last 6 months." And that is what lean in manufacturing means. And it's astounding if you look at the numbers in different industries, and especially in 3D printing, what you can do by using smart methods to optimize throughput, how much more you can eke out of the same equipment. It's really fun to see and to do, and it's cool.
Great. Let's talk about the products a little bit, about what people actually use you guys for. What's the breakdown between consumer and enterprise, or B2B parts and that type of thing?
Yeah, that's a tough question in one way, because I think the whole contrast between B2B and B2C is completely disappearing. Someone with a great idea who uploads a design might sell one first, and you could call it a designer or a consumer, but then when they start a business around that, and excellent examples exist plenty, all of a sudden they're a business, and then they're selling to consumers through Shapeways. We have corporate accounts that use Shapeways, typically privately, so I won't talk about them, but big names. But the majority of our customers are individuals, designers, shop owners, smart people, entrepreneurs who love to bring their ideas of not only products, but even a brand to life on Shapeways.
Interesting. And you had you announced recently a partnership with DJI. Is that right?
Yep.
So to build, what was it, like spare parts for drones?
Well, actually more accessories.
More accessories.
So the partnership was all about like amplifying what the community was already doing. So I happen to also love drones, and what I saw happening on the site is that several smart guys figured out that there was a huge market for accessories for drones, DJI drones in particular. One of our fastest growing shop owners was a student from the Netherlands who was selling like thousands of dollars worth of accessories every month. And we simply reached out to DJI and said, do you guys know this is happening? Have you seen how many parts we're making for your drones? And they were amped. And we decided to do a contest. We decided to do some cross promotion just to make sure that people buying the drones knew there was a big ability to not only make your own accessories, but there were already many existing accessories, and vice versa. You know, making sure that we incentivize the community a little bit to even get crazier than they already were, and that worked.
Okay, so still on the product front, where do you stand on the whole copyright and brand aspect? Was this a little bit like Napster and music when it came out? The big fear with 3D printing was that it would be a copyright nightmare. And I know you've done some deals like Hasbro and others, but I'm curious about how you think about those issues.
Yeah, I think it luckily isn't a big problem yet, and hope that it remains like that. I think Hasbro was a great trailblazer in the sense that they figured out that instead of block, might as well enable. And there are very easy ways, especially with a slightly more controlled environment as a platform like ours, to do interesting deals where you make something based on a brand, the brand knows about this and enables you to do it, and then you split the revenue a little bit. We get some money for making it, the designer gets some money for coming up with this crazy idea of the cool accessory or whatever it might be, and then the brand gets a little bit for owning the brand rights, and everybody happy. Instead of blocking, let's enable. Mm-hmm. And I hope we can do many more of those deals, because, and this is coming to something I'm really passionate about, it starts to flip around the way we think about products and how products go to market. Instead of big companies pushing, Hasbro has great brands, but those brands push merchandise into the market and they hope it lands, right? This is the big company approach, and with mass manufacturing we had no alternative. But 3D printing as a manufacturing technology enables us to make one-offs and 10-offs and 100-offs, and as a result the community can start testing and making beautiful products that may be relevant for only them or maybe for a large group. And in that way the brand can see what actually resonates with a larger audience, that their brand is a larger audience, a fan base of their brand, and as a result it's more of a pool because they see it happening right in front of them, and then they can reach out to the most successful designers and say, hey, would you mind if we take your design and mass manufacture it, and we come up with a type of a deal that is good for all of us again. Mm-hmm. And I think that's the future of products, where we prototype products first and test them live in the market. And that's why I like some of the topics of the talks this evening, about going into the market fast, making sure that you have real customers, that you get feedback. One of the things with 3D printing is that you can get iterative design. With mass manufacturing you have 1,000 items, you need to sell them. 3D printing you only make after people buy, and if it doesn't work or it doesn't fit, you get that feedback, you change the design slightly and you give an updated version. It's almost like what we've done with software. Mm-hmm. And the closer we can get to that, I think amazing things will happen.
Mm-hmm. That's fascinating. So that brings us to the sort of the third part of the discussion around the future of 3D printing. So if everything goes according to plan and the technology is improving and all the things, so do you see 3D printing as I guess an addition to the manufacturing process along the lines of what you were just describing, or do you see a future where at least parts of the manufacturing world could be completely replaced by 3D printing? So if you think of a company like Harry's that makes simple, nice but simple razors, it's a brand new company and they decided to buy a factory in Germany for $100 million. Is there a future where the next Harry's in 10 years from now will instead decide to build a 3D printing factory?
Yeah, or use the cloud, right? Yes. Just like we don't build our own computers anymore that we put in co-locations, we just use S3 or whatever to host our service and our servers. There are different ways we will make things. I do think that for certain categories of products, we will start to see that more and more will be made using 3D printing. And for other products, it probably will make sense to keep making them using traditional ways. But over time, I definitely see in, jewelry, gadgets, toys, home decor, in those categories, I wouldn't be surprised if in the next 5 to 10 years, 10% or more of those products will be made using 3D printing, because the products fit the technology of 3D printing we now see, because people want everything to be exactly custom and just made for them. And as a result, I might actually be underestimating the amount, because we're in the beginning of I think an exponential takeoff of the technology. It's been used for prototyping for long and the growth was pretty slow. But as people now starting to realize how much potential this technology has for making stuff, you start to see that R&D is picking up substantially. The amount of time and resources HP is pouring into their 3D printer effort is pretty astounding to see that. And that will have some profound impact on the industry. And as a result, more people start, carbon is a great example again. They seem to be...
Talk about carbon?
Yep.
Tell people what it is.
Tell people, yep. It's a new type of 3D printer that is, coming out of a startup that is, a new technology that's really fast 3D printing. So those are just the examples that more and more money is going into the industry. And we've seen that before with the internet, for example. As that started to accelerate. The internet was around for over 10 years before people started to pay attention. My friends asked me in '92, why are you on the internet? What are you going to do? Who are you going to email? Nobody. And they were right. But just, I love the technology. And then 2 years later, everybody had an email address. And 4 years later, everybody that I knew was online, including our neighbors and people that had absolutely 3 years before no reason to be online. Everybody was. So it's that quickly. And I think with 3D printing, we might see a similar adaptation curve, maybe even faster.
So what's the sort of step function that takes us there from this, very interesting but sort of slow ramp to that moment? Is it having a bunch of products that become hits? Or is that a pure technology? Is that a question of technology or a question of sort of use case?
I think it's a bit of both, right? We fixed a few really hard problems already. Cost was a complete prohibitor at the beginning. That's removed. We can now print an iPhone case easily for like 15, 18 bucks. So that's less than you pay for a reasonable iPhone case in stores. Then usability. Yeah, 3D software is really hard. So I think customization of existing stuff is going to be really, really powerful, and we're making huge steps there. And the computing power is now getting there, that you can real time change shapes and feed that back in the browser to the end user. So you basically get a sense of customizing, shaping stuff in your browser in real time, and that you get the confidence that what you've just made is both beautiful, useful, and just what you need. So that technology is with OpenCL and live streaming, the network capacity is there. So we start to be able to do that. And then I think 3D scanning is coming of age. That was cool to see the IntelliSense demo just now, but I think 3D scanning might be a crowd starter, might be the killer app, especially scanning people. That was a bit of a gig we did a few years back at South by, and we were here at the Museum of Art and Design, but the lines were out the door and people buy those things like crazy. And maybe it's the first thing people buy, 3D printed, and then start to figuring out well, wait a minute, if this is possible, what else can I do?
And just a quick question to what you said, the cost part. So I know iPhone cases can be done for smaller amounts of money, but help us understand where the cost fundamentally is to build something more complex, and for it to truly take off. Is that the materials are expensive? Is that because you need a lot of people involved? Is that where does the cost come from?
It's multiple things. The raw material is still too expensive because it's not used enough, and it's a special raw material you need. It's basically the materials we all know, but they have to be prepared for 3D printing, and as a result they're expensive. The machines are built in too low volume, and as a result the machines are way too expensive. I always joked with EOS, one of our good friends, their big machines cost $1 million, but they're less complex than a Volkswagen Rabbit. So why would I be spending more than $30,000 on one of their machines? Well, I know because I have to pay for all of the R&D. When more and more people buy those machines, those prices come down, and the machines need to get faster too. One of the things that HP really understood is that their machines are 10 times faster than anything the market currently has seen. As a result, people get their stuff faster, one of the very important things. So getting it faster, getting the quality up, there's no full color plastic yet. You know, you can print in plastic, but there is no way that you can have a picture on the back of your iPhone case. Really, come on. So that's being fixed by HP. The product isn't there yet, so we need more materials, we need it faster, we want it cheaper, and then adaptation will, at some point, will just skyrocket, because if something costs that you're willing to spend 20 bucks on costs 100 bucks, you're never gonna do it. When it's 40, some people might do it, and when you hit 20, everybody does it. And then you get these like step function explosions that we're definitely starting to see. Like for jewelry, we're already seeing it, because like silver rings cost 30, 40 bucks. That's doable, and that's what people expect to be paying. So that's where we already start to see that people really go nuts. But with the plastics, we have some work to do, and that's why I'm so excited to be working with HP on their new machine.
Yeah. And maybe to close before opening to questions, people. It's very interesting. You and I were chatting about this earlier. About this concept of mass customization has also potentially a very profound impact on how things are sold. So there's the iteration concept that you mentioned earlier, but I guess it almost leads to a redefinition of marketing and advertising itself. Like, how do you see that evolving?
Yeah, I think that's a topic for a whole chat by itself, but I think that we are not realizing how much our society has been shaped by mass manufacturing. You know, we have big companies because mass manufacturing requires big capital, big companies to do mass manufacturing. We need marketing because we need to first figure out what people want in the old way, and then we need to push it when we have it, so everybody is aware of it and they buy it, whether they like it or not, maybe in some cases. And then we need big design departments in those companies or outside to figure out how those products get prototyped, and then we have focus groups and all that stuff. So you have a huge waterfall approach, and as a result, you know, bringing a product to market takes an enormous amount of capital. It takes an enormous amount of risk taking, because if it's the wrong product, you're gonna suffer big time, and big companies have gone through those processes, so they get even more risk averse. And as a result, we are only seeing a handful of products that come out into the market. I think with 3D printing, as I said before, also around the IP, you know, we see things going to be flipped upside down completely, because there is no risk of bringing a product to market, because it's only the time you spend behind your computer designing it. You don't have to pre-manufacture anything. When a customer buys it, it gets made. The time to market completely collapses from months to days, and we see that, like after the Super Bowl, Left Shark and Right Shark were on our site one day after, and people start buying them like nuts. That was fun. And as a result, you know, because of all those dynamics, when people start giving feedback on the product, you can change the product very quickly. And I love to see the parallel between how software went from a mass product before the internet to where it is now, where we continuously change, we fork, we work together, we split off, we merge, and that will start happening to physical products, because the technology to turn them from a digital thing into a physical thing, and on the other way around, from a real thing into a digital thing again, is becoming ubiquitous, and as a result, things fundamentally will change. I mean, you meet people 16 years old, they want to set up their own jewelry line. Like 5 years ago, if you're 16 years old and you want to set up your own jewelry line, you're nuts. You know, go to school, study, join a big company. Maybe in 10 years from now, you'll be good enough that you can set up your own jewelry line. Now they just do it. And some of them are successful because they sell well. And I think that's a fundamental change that we're starting to understand just now, but 5 years in the future will be something that is pretty common. And that's really cool to see happening right in front of us.
Terrific. All right, I want to open to questions. I want to hear. Oops.
One of the issues that you deal with in terms of working prior to 3D printing is dealing with the software. where do you see CAD going, or do you see it as a barrier to greater use of 3D printing, or will there be some other technologies, such as scanning or something else, that will sort of eliminate that issue?
Yep. So definitely true. 5 years ago, or maybe 10 years ago, CAD software was almost one of the only ways to really get something you could print. This is quickly changing. Scanning is helping with that because you can scan yourself, and then if you have some really cool tools that are becoming now easy enough that you can put them in a web browser where you can merge existing things. So for instance, scan your dog, scale them down, take a ring that is big enough for your keychains, merge that into your dog's scan, and then print it, and all of a sudden you have a keychain hanger based on a scan of your dog. That's something that should be doable in the next couple of months in the browser with some code that you use on our platform. And that you can do those kind of creative things without the need of having hard software is cool. And I think Autodesk is doing a lot of cool stuff there as well, making very accessible 3D software. We have long ways to go still, but it's getting easier in a hurry, and that's great.
Do you offer Conductive Ink? Does your factory have printers that print out Conductive Ink? Do you use the integrated circuit?
Yep, so Conductive Ink is not available in any of the technologies we currently offer yet, but it's one of the things that HP has in their roadmap. And that is really going to be cool, because if you mix plastic with Conductive Ink, the next generation of 3D printed houses for things that you could make with electronics are going to be really cool. Just, the battery adapter is going to be printed, the cabling is going to be printed, so I can't wait for that, to see the first things with that. Yeah, but from our perspective, it's probably a year or more out before that will be mainstream.
Yep. That's fine.
Earlier this year, there was this talk at TED about this 3D printer which can grow an object like a Terminator. And the speaker said that that is going to speed up 3D printing by 100 to 1,000 times. So what do you think about that, and what's your take on organically growing 3D printing?
So what is the printer code you're talking about?
No, there was this talk in TED. It was basically growing an object like how Terminator 2, like how the body, so what's your take on those technologies?
Yeah, so the TED talk you're referring to is from a company called Carbon 3D. And yeah, I mean, one of the things that they really clearly show is that, the old technology of 3D printing was really slow. Some people called it rapid prototyping, I disagree. But they're getting faster, and they need to become faster because you're making one item. And if you have 1,000 people who want something, or just like we did with Google, we printed 250,000 bracelets, you need some capacity and you need some speed. People expect to order today, get it tomorrow. So any advancements there is great. So Carbon is onto something, just like other companies who are realizing that speed is important. I think it's a big step in the right direction, but I think it can go faster still. Sure.
Thank you. I think you are running an amazing business. It's very inspiring. You commented on the Conductive Ink. Can you comment on the fundamental limitations of the 3D printing technology? Is there anything that, in terms of resolution or longevity or anything else that is fundamental limiting this very, very approach?
Fundamental limitations to 3D printing. Good question. Well, if you realize that at MIT they're actually already doing atom stacking or approaches to atom stacking for several years, we'll be able to start engineering or actually printing new materials. And I'm not talking about, approaches to new materials, but really new materials that we haven't seen before. So I think the limitations of this technology we haven't even scratched the surface of. This is like the internet using phone lines and very old BP modems connecting universities. That is where we are if you take the comparison to the internet. I can't wait to see fiber connections, but it's kind of scary because we will be creating new products, new materials, new capabilities we haven't seen before. And that's why this is so cool. but it's a little bit hard to predict what will come next. Yeah, it's going to be it's going to be a lot of fun.
Okay, time for one more. There was one here. Yes.
Sure.
Thank you.
Hi, I heard about how fantastic your porcelain is, and I was just wondering if you could tell us a little bit about that achievement and what people are going to do with it.
Sure. So, you know, the fun thing about having a platform, enabling a community to make whatever they want, is that you start you sometimes discover cool things, and we try to experiment as much as we can. Although we're now 7 and a bit old, we still try to, be as agile and as lean as possible, behave like a startup. And we figured that we met a company first that did some printing in ceramic, and people start to make, coffee mugs, vases, fruit bowls, that kind of stuff. And I went like, oh yeah, of course. There's, materials and products are very closely aligned. Who wants to drink from a plastic 3D printed coffee cup? You want to have porcelain, right? Unfortunately, the quality of the product that we then offered was not as good as we believed it should be. It wasn't completely dense, which means if you looked at it and you ticked it, it broke. It wasn't dishwasher safe to the point that we believed it should be. And we worked with a really great guy who had an idea on how to do this much, much better. And as a result, after quite a bit of time, it was not easy, we developed a process to make 100% dense porcelain. And I've seen trials of what we can do. Like, we are probably not going to support that in the beginning, but we can go down to 1 millimeter wall thickness on cups, and you can almost see through. If you hold it against the light, you see through, and then any shape you want. So yeah, materials make the product, and with porcelain, a new category of materials of products is going to be opened up, and that's kind of cool.
All right, well, on this note, thank you so much, Peter, for being here. This was terrific. I enjoyed it. Thank you.
All right, my pleasure.